All right, this video is about a production possibilities curve. So first off, production possibilities curve is the first economic model that we're going to be talking about. So if you remember, an economic model is simplifying reality. We're talking about trying to make the economy a little bit easier to understand. And so what we're going to do is we're going to look at two possible things that could be produced. And then we're going to graph it. So first thing is that in class I had given these two squares, so these two little sets here, out to every single person in class. And I asked them, and I said that these two little slips of paper were their pieces of land. Okay? And so they could decide what they wanted to do with their pieces of land. They could either produce triangles or squares, or some sort of combination of both. So they could go and produce as many triangles as squares as they could with these two little slips of paper. So as you can see that they could be divided into a couple of different options, right? So different options as far as triangles or squares. I gave everybody some scissors, and I gave them a little bit of time to make the decision about how many squares and how many triangles there are. So now I'm going to go through and show you what that actually looked like. So I had everybody go and add to their notebook this chart over here. So this chart right here. Okay, I had everybody add that to their notebook, and we're filling in how many triangles and squares they made. So first question I asked was, okay, was there anybody out there that made all triangles? So there's some people that raised their hand and said, yep, I made all triangles. So I asked them, well, how many triangles did you make? So if you count, you can go and make 1, 2, 3, 4, 5, 6, 7, 8. If you divide this all up into triangles. So you could make potentially 8 triangles. And how many squares does that make? 0. So we're going to make 0 squares. So then I asked, okay, was there anybody that made just one square? One square. Well, if you make one square, so if you follow here, here's one square, that means you have 1, 2, 3, 4, 5, 6 triangles left. So 1 square, 6 triangles. So then I asked, okay, was there anybody that made 2 squares? So if you're making 2 squares, here's the 1 square, here's the 2nd square. So that means you have 1, 2, 3, 4 triangles. So 2 squares, 4 triangles. And then I ask, okay, was there anybody that made 3 squares? So if you made 3 squares, you had 1 square, you had 2 squares, and you had 3 squares, which means you had 1, 2 triangles. So 3 squares, 2 triangles. And then lastly, I ask if there's anybody that just made all squares. Because if you made all squares, you'll notice you have 1 square that you made here, 1 square that you made there, 1 square that you made there, and 1 square that you made there. So there's 4 squares and 0 triangles. Now, ignore the last column for just a second. Here's what we're going to do with this. The production possibilities curve is going to be looking at the combination of these two items that you could produce. So remember, I gave everybody these two sets of squares, or 2 sets of paper that they could choose from. So now what they're going to do is we're going to plot the points that we just talked about in this table. So I'm going to put all of my triangles on the y-axis, and I'm going to put the squares on my x-axis. So now, notice that my triangles, I went all the way up to 8, so I'm going to go and make 8 little hash marks here. And my squares went up to 4, so 1, 2, 3, and 4. And now I'm going to plot my points. So at point A, I have 0 squares and 8 triangles. So 0, remember, is here. So here's 0 squares. 8 triangles there's going to be up here. So I'm going to label this as my point A. And then at point B, I have 1 square and 6 triangles. So 1 square is here, 6 triangles is here. So I'm going to put a point here, and I'm going to label that point B. Then I have point C is 2 squares and 4 triangles. So 2 squares and 4 triangles is about here. I'm going to lay that point C. And then I have a point D is 3 squares and 2 triangles. So I'm going to get 3 squares, 2 triangles is approximately there. And that's my point D. And then point E is 4 squares and no triangles. So we're going to put that there and label that point E. And now I'm going to use my handy dandy tool to draw a nice straight line, because I cannot draw a straight line to save my life. And I'm going to connect my dots, and it's approximately there. Okay? All right, so that is my production possibilities curve. Now, the thing is that you can tell a lot with using a production possibilities curve. So this was also what I had everybody add to their notebook. So first thing that you can tell is, number 1, you can tell where you are most efficient, or your fullest potential. So if you think about it, okay, anything that you chose to make, or the people in class chose to make, that falls on my red line here is efficient, because efficiency is all about using your resources wisely. So if you produce some sort of combination in here, so you had some sort of combination on this red line, then you are efficient, because you're using all the paper that I gave you, you're using the scissors, you're using the people. So this is going to be anything that's on the line. So if that's the case, could you produce at point Q here, where you have 3 triangles and 1 square? Well, yes, you could. But is that the best idea? Well, think about it. If you produce 3 triangles, or you have 3 triangles and 1 square, that means that I'm going to produce, here's 1 triangle, here's 2 triangles, here's 3 triangles, and then I have 1 square. So I have 1 square right there. The problem with that is that all the stuff that is, I'm going to highlight here, all this, I'm not using. I'm wasting that. So that's not a good idea. So Q is possible. I could produce there, but it's not the best idea. So anything inside the curve, we're going to say has idle resources or wasted resources. So in this case, what we have happening is that we have resources are there, but they're not being used to their fullest potential. So it's wasteful. You have paper that's left up here that you're not using, right? So that's not a good idea. So we don't want to make there. Okay, so if that's the case, then could I go and produce this combination, having 4 triangles and 3 squares? Well, remember that red line is our fullest potential. That's based off from how much paper I have, how many people I have, how many scissors I have. So point Z is not currently possible. So anything outside the curve is not currently possible without economic growth. Well, what does that mean? Well, could I do something or change something to get to point Z? Yeah. What about if I, for example, gave people more paper? Okay, they could definitely produce more triangles and squares. What if I gave them more scissors? They could go and cut it up into smaller pieces. That could work. So this could be getting more resources or getting more training. All right. So then we can talk about trade-offs and opportunity costs. So if you remember when we talked about trade-offs in class, we talked about trade-offs are all the possible options not chosen. So if that's the case, all possible options not chosen, let's say that when you were making triangles and squares that you decided to produce at point D. All right, if you produce at point D, that means you're foregoing all the other options that are possible. So what are the other points on here that are possible? Well, it's going to be anything that's on the line. So any points on the line and anything inside the line or curve. So anything inside the line, like for example Q, because Q is possible. It's not the best place to be, but it is possible. So we're saying that that is also a trade-off. Now if you remember when we talked about trade-offs, we also talked about opportunity cost. Okay, so opportunity cost is, remember, the second choice, the runner-up, whatever you're giving up because you make one choice instead of another. Well, I said that we're picking point D, but what if my second choice was point C? So what if I had been at point C and then I moved to point D? Okay, what does that mean? That means that I am going to be giving something up. Okay, now if you look over here at this chart, I do have a column where it says opportunity cost per square. So let's talk about this first and then we'll go back to my C to D. So opportunity cost per square. What this means is that how many triangles do I have to give up to get one square? So for example, going from point A to point B, okay, I'm going from 0 squares to 1 square. Well, in order to get 1 square, how many triangles do I have to give up? 2, right? Because I go from 8 to 6. So my opportunity cost is 2. Well, going from B to C, in order to get 1 more square, how many triangles do I have to give up? Again, 2. Going from C to D, how many triangles do I have to give up? Again, 2. And going from D to E, I have to again give up 2. Now, you may ask yourself, why didn't I fill in an opportunity cost for point A? Well, if you think about it, we didn't change anything. We didn't get any squares, so there's nothing that we can put in there. But notice that it's a constant opportunity cost where we're always giving up 2 triangles to get 1 square. Well, now let's go back to my question over here where I said to go from C to D, so I'm losing how many triangles to get 1 square? Again, 2. Okay? But what if I want to reverse it? What if I wanted to go from D to C? How many squares do I have to give up to get 1 triangle? Ah, that one's harder. If I want to get 1 triangle, I'm only going to give up half a square. So if I wanted to reverse this column and I wanted to talk about it in terms of triangles, opportunity cost per triangle, you would find that it would be the reverse and it would be half a square. Okay, so this hopefully makes sense, and this is a nice, neat, lovely little line. But here's the problem is that it's not always so nice and neat, because sometimes what happens is that sometimes your resources are not equally suited for both items. And so, for example, let's say that instead of producing squares and triangles, what if we're talking about carrots and apples? So the second part of the PPC demonstration that I did in class was that I handed out these cards to 3 different people in class. So I picked out 3 people, one that was really tall, as evidenced by my very bad stick figure, one that was medium sized, and one that was on the shorter side. So we gave each of these three people these cards, and we're going to say that they could either pick carrots or pick apples. Now, if you think about it, carrots, you just have to bend over and pick up and pull it out of the ground. Apples, you have to reach up and pull off the tree. So here's the thing with this one is that we're going to have them all three start off where they're going to be producing carrots. Okay? And all three of them can pull 1 carrot each. And that means that they're not going to be making any apples. So when we graph this on a PPC, we have 3 carrots being pulled and 0 apples. So I'm going to put a dot here on my PPC and label that point A. And then we decide maybe, okay, we want some apples. And so we're going to actually have one of these people switch to apple production instead of carrots. So if you think about it, who should naturally be pulling apples instead of carrots? Well, obviously it should be the person that's the tallest. So we're going to take them off carrot production and we're going to have them produce apples, which means now we have 2 carrots, 1, 2, and we have 5 apples. So now I'm going to put a dot here and label that point B. And then we're going to say, okay, we want more apples, and so maybe we're going to pull another person off carrot production, and we're going to have them produce apples. So the next logical person is the medium-sized person, and we're going to have them pull off carrots, and we're going to have them produce apples. So now we only have 1 carrot left being produced, and we have 8 apples. So 1 carrot and 8 apples is going to be approximately here. Okay? And then if we pull our last person off carrot production and we just produce apples, okay, we have 0 carrots, and now we have 9 apples. So that's going to be about here. Now, if you connect my dots here, you'll notice that this curve is not really a straight line. It's going to be more curved. It's going to be what we call more bowed out. When I draw it normally, it'll be like this, right? What that means is that if you look at it, it's not a steady opportunity cost, just not like our squares and triangles that we did, where it was a steady, you give up 2 triangles for every square you want. Here, it varies depending upon how many for each carrot that I was going to get, I had to give up more and more apples. Or you could look at it from the opposite perspective. To get 1 more apple, okay, I had to give up less and less carrots. Or more and more carrots. So that when we have a curve that's what we call bowed out like this, so bowed out PPC, this is because of increasing opportunity costs. You have to give up more and more to be able to get this other item. So that's the only difference between the squares and triangles and this apples and carrots example. But I wanted to show you both examples to be able to make sure you understand that sometimes the curve is a straight line like our squares and triangles, and sometimes it's bowed out like our apples and carrots. All right, that's all I wanted to do. Please let me know if you have any questions.